Hello, this is the LGate 120 and 320 Installation Training Guide. This guide will provide a product overview to the LGate 120 and 320 meter. We'll go over basic hardware installation and some best practices, as well as providing a few considerations for post-installation operations and maintenance. To start things off, here are the basic specs for the LGate 120 meter. This is a Form 2S socket meter for single-phase PV monitoring. It's rated 120 to 480 volts AC nominal input and 200 amps max. The LGate 120 is a cellular-enabled gateway with Ethernet backup. Certifications for this meter include ANSI C12.20. This meter is rated to 0.2% accuracy. In addition, the meter has received FCC Part 15B and PT-CRB certification. As a device on the AT&T cellular network, the LGate 120 has received AT&T carrier certification. And here we have the specs for the LGate 320. This is a Form 16S socket meter for three-phase PV system monitoring. It's rated to 120 to 480 volts AC nominal input and 320 amps max. The LGate 120 is also a cellular-enabled gateway with Ethernet backup. The certifications for the LGate 320 are the same as for the LGate 120. Now, as you may have noticed, the LGate 120 and 320 look very similar. This is because these meters share the same internal data logger, cellular modem, and meter housing, so the same basic features and functionality for these meters are the same. The cell modem is inside the LGate socket meter. Now, the LCD screen, front and center, displays instantaneous power, voltage, and amperage readings for easy on-site installation verification. The MAC address is printed above the LCD screen, and the power meter serial number is printed just below. Attached to the base of the LGate are two cables. One of these cables provides RS-485 wires for monitoring external devices, such as inverter direct. The other is a Cat5 cable for establishing the backup Ethernet connection. These meters are pre-programmed with our latest firmware version. If the LGate requires a firmware or device configuration update post-installation, we can send these updates over the air without having to have someone log in to manually program new settings. These LGates will check for new updates on a regular schedule, which means that we can post an update for the LGate without having to ping it over the AT&T network or the local area network. The LGate will automatically download the update when it checks in on schedule. Now, the LGate 120 dataset includes interval and lifetime energy, power, line to neutral voltage, and net current. In addition, the LGate 120 will measure AC frequency, power factor, reactive and apparent power, and phase angle. This expanded dataset provides much greater insight into site commissioning and post-installation O&M. In addition to these variables, the LGate 320 measures line to neutral voltage by phase and current by phase. So we've expanded the dataset with these new meters, but we've also simplified the installation. Here's how the LGate 120 differs from our previous model, the LGate 101E. Now, unlike with the LGate 101, the LGate 120 does not require an external CT to measure PV system output. This eliminates the possibility for one very common point of installation error. In addition, the LGate 120 does not require a separate voltage reference from a dedicated 2-pole breaker on the electrical service panel. Another key difference lies in establishing the data connection. the LGate 101 requires a hardwired Ethernet or Ethernet over powerline connection to the local area network, which in many cases means that the installer must enter the building to access network devices. The cellular-enabled LGate 120 with Ethernet backup provides multiple options for establishing a data connection. As for site commissioning, the LCD screen on the LGate 120 is extremely easy to read, and it provides far more information than the LED indicator lights on the LGate 101E. In a similar vein, the LGate 320 provides for much simpler installation over a similar model, the LGate 310, which requires a separate LGate 101E data logger and Itron Sentinel power meter. The LGate 320 combines these pieces of equipment into one, so the data logger and power meter are combined. Another key difference is that the LGate 120 and 320 are far more accurate than the LGate 101 and the 310. The new meters are rated to 0.2% accuracy versus 0.5%. One thing that hasn't changed is the sampling interval. The LGate 120 and 320 will measure data every 5 minutes. These data readings will be uploaded to Locus servers every hour, which is important to keep in mind as you set the system disconnect alert threshold on SolarOS. Now these LGates have the same internal memory capacity as the LGate 101E, which is 2 months of onboard storage. If the data connection is temporarily disrupted, the LGate will store the data and upload everything to Locus servers as soon as the connection is restored. Now that we've covered the basic features and functionality, I'll go over a basic hardware installation for each meter. Provide a few pre-installation considerations, such as where to site the LGate and how to wire the meter. I'll go over setting up inverter direct monitoring, and finally, how to establish a data connection. Here we have an overview of the LGate 120 installation. The cellular meter will be mounted in a meter socket between the PV system and the main panel. The AC lines will run through the meter socket line to load. Here, an overview of the LGate 320 installation. This meter will also be mounted in a meter socket between the PV system and the main panel, with the AC lines run through the meter socket line to load. Now that we've covered the general line diagram, let's talk about a few things to keep in mind to ensure a successful installation. The first pre-installation consideration is choosing a single-phase meter socket for the LGate 120. Now these meters will not ship with a meter socket. There are a number of compatible models on the market, but they must meet the following specs. The meter socket should be form 2S, rated to 200 amps minimum and 600 volts AC. We recommend getting a meter socket with an all-weather rating, particularly for outdoor installations. In this diagram, the lug for L1 is on the left and L2 on the right. Ground is found in the middle of this meter socket. Just to note, neutral can be run through the meter socket for the LGate 120, but it should not be terminated. For the LGate 320, it's important to select a meter socket with the following specs. It should be form 16S, rated 320 amps minimum and 600 volts AC. The LGate 320 requires neutral, whether you have a Y or Delta system. We recommend getting a meter socket with an all-weather rating for the LGate 320 as well. In this diagram, you can see the lugs for A, B, and C, along with ground and neutral in the center. Another important pre-install consideration is where to site the LGate. We recommend siting the LGate near the inverters and electrical service panel in an area with strong cell reception. Keep in mind that building interiors can weaken the cell signal. A good rule of thumb is to install the LGate where you would expect to get a signal on your cell phone. We also recommend siting the LGate in the shade and out of direct sunlight whenever possible. With these considerations in mind, the first step in the actual installation is to mount the meter base between the inverter and the service panel. Now, the RS-485 cable attached to the base of the LGate 120 and 320 is 6 feet in length. If you'll be setting up inverter direct monitoring, we recommend siting the LGate within 6 feet of the inverter, so you won't need to extend that RS-485 cable. Now, if there are multiple inverters, it's important to combine the AC loads at a load center and not at the socket itself. After mounting the meter base, run the AC lines from the combined inverter output through the meter socket, line to load. Land the AC lines at the PV breaker on the electrical panel and ground the meter socket to ground in the main panel. Now for the LGate 320, we'll be running the AC lines combined inverter output through the meter socket, line to load, so that's top to bottom. Ensure that you run neutral and land ground to ground at the main panel. Final steps in the meter installation. First is to attach the LGate meter to the meter socket by carefully sliding the meter tabs into the jaws. Secure the cover on the meter socket. We recommend using zip ties to secure any unused RS-485 and Ethernet cable inside the meter socket. Finally, flip the AC and DC disconnects and power on the inverters. To verify meter installation after startup, check the arrow on the LCD screen, which is shown here in the lower right corner. This arrow indicates the direction of energy flowing through the meter socket. If the arrow points to the right, the meter was installed correctly and we're getting positive power readings. If the arrow is pointing to the left and the PV system is currently generating energy, this means that the meter socket was installed backwards. You should verify that the AC lines from the inverter run line to load or top to bottom. Next, verify that the power, voltage, and current readings match the inverter output by checking what's displayed on the LCD screen. Now, if you're considering inverter direct monitoring, here's how to set up that connection. First step is to cut the heat shrink wrap off the RS-485 arm to expose the internal Cat5 cable. Next, use shielded, twisted pair wire to connect this cable to the inverter. Always join cables using gel-filled B-wire crimp connectors. And be sure to join the cable in a junction box and not within the meter socket. RS-485 cable should always run in separate conduit from high voltage AC lines. Here we have the two common RS-485 wire connection methods for inverter direct monitoring, 2-wire and 4-wire. We'll be using the blue, blue-white, brown, and brown-white wires, which translate to the RX and TX positive and negative ports on the LGate 101. For 2-wire inverters, crimp the blue with brown and the blue-white with brown-white. From here, the blue, blue-white, and green wires should be connected to inverter positive, negative, and ground. For 4-wire connection methods, such as with Fronius and Eaton inverters, wire the blue, blue-white, brown, brown-white, and orange wires to the inverter. After setting up these connections, you can verify inverter direct connectivity by checking the binary switch icon on the LCD screen. This icon, shown here circled in red, indicates communication status for all RS-485 and Modbus devices. If the switch is on, as it's displayed here, all external devices are communicating correctly and are sending data to the LGate. If the switch is off and you don't see it at all, at least one of those external devices is not communicating, or the LGate has not been configured to communicate with external devices. Now the final step in the installation process is establishing the data connection. We've designed the LGate 120 and 320 to maximize flexibility. We expect most installations to use the preferred connection method, which is the cell modem. With this method, no additional configuration is necessary. It's really just plug and play. If a cell connection isn't possible, perhaps you're in an area with weak cell reception, a secondary method is Ethernet cable. To set this up, connect the LGate to a DHCP router with a Cat5 Ethernet cable. Always run this Ethernet cable in separate conduit from power conductors, and keep the length of this cable to 300 feet or less. Some additional configuration is required for the secondary connection method with Ethernet cable. To enable the Ethernet connection, you'll need to log in to the LGate directly using a laptop and the LGate's Ethernet cable. After setting this up, you'll open a web browser, enter the default IP address 169.254.12.13 in the address bar. Enter the password networkconfig, all lowercase, to log in to the configuration page. Here's what you'll see when you log in. In the left-hand panel, you can view instantaneous readings for the LGate and external devices. To enable the Ethernet connection, we'll be focusing on the Network Settings panel on the right. The required configuration settings are the cell mode and DHCP mode. The default setting for DHCP mode is enabled. We'll leave this as is. The one thing that we need to change is the cell mode. We'll change this from false to true. Then select the Save Configuration button. After making this change, the LGate Ethernet connection will now be enabled. Keep in mind that the LGate cannot manually switch between an Ethernet connection and a cellular connection. So anytime you need to adjust the connection method, you'll need to log in and manually change these settings. Now, if you're setting up an Ethernet connection on a local area network that requires a static IP address, you can change these settings by logging in. In the Network Settings panel on the right-hand side of the configuration page, we'll be setting a number of parameters. The cell mode should be switched to false, and DHCP mode to disabled. You'll set the static IP address, gateway, netmask, and DNS. Hit the Save Configuration page, but before doing so, be sure to note the static IP address that you entered, as you won't be able to obtain this information after making these changes. After saving configuration, the LGate will be enabled to communicate using the programmed static IP address. Now, whether you're setting up an Ethernet connection or using the preferred connection method of the cellular modem, you can verify the data connection while on site by checking the phone icon. There are three options for this icon. A solid phone icon, as you'll see here, means that the last data upload was successful. The LGate is able to connect to our network and is sending data. If the phone icon is blinking, the last data upload failed, or if after initial startup, the LGate is just searching for the network. The blinking speed indicates cell strength. The faster the blink, the stronger the signal. If there's no phone icon, this indicates that the LGate is not currently connected to the network. Now, to think about the speed of the blinking phone icon, we can translate that to the bars on a cell phone. If you're not seeing a phone icon, this would be like seeing 0 bars on your cell phone, so the LGate won't be able to communicate with our network. If you're seeing a blinking phone icon, this would be like 1 or more bars on a cell phone. It may take a little while for the LGate to establish the initial connection, but it will be able to. If you're seeing a solid phone icon, this means that there's a very strong connection, and the LGate is currently sending data to the network. Now that we've gone over the basic installation, we'll discuss a few best practices for commissioning, establishing a data connection, and troubleshooting. To commission the LGate 120 and 320, we recommend installing the LGate in an area with strong cell reception. Always run the AC lines through the meter base, line to load, top to bottom. After completing the initial installation, always verify that the LGate power readings match the combined inverter output by checking what's displayed on the LCD screen. Ensure that the arrow on the LCD screen points to the right. Lastly, verify that the LGate displays a blinking solid phone icon, which indicates that the LGate will be able to transmit data. Establishing a data connection is an important step in site commissioning. Here's an easy troubleshooting diagram to ensure that the LGate will be able to transmit data to our servers. The first step is to determine whether the phone icon on the LCD display is solid. If yes, the installation is successful and the LGate will be able to transmit data. If not, the next step is to determine whether the phone icon is blinking or off. If the phone icon is blinking, the LGate has not yet established a connection with the AT&T network. It's searching for this network and will eventually connect. It may just take a little while longer. If the phone icon is off, we recommend searching for a stronger signal. If the phone icon is then blinking after relocating the LGate, this can be considered a successful installation. If the phone icon remains off, we recommend setting up the backup Ethernet connection by connecting the LGate to a DHCP router on the local area network. After setting up the backup Ethernet connection and logging into the LGate to enable the Ethernet connection, check back on the phone icon. If this icon is solid, the LGate is successfully connected to the local area network and will be able to transmit data. During the site commissioning process, there are a few common issues that may arise. Here are a few troubleshooting steps to follow if you encounter any of these issues. The first potential issue is that we're receiving negative data readings from the LGate. We recommend verifying that the AC lines were run through the meter socket line to load, top to bottom, and checking that the arrow on the LCD screen is pointing to the right, not to the left. The second case is if the LGate data readings do not match the inverter output. In this case, we recommend checking that the AC lines are securely connected to the tabs at the meter socket. If there are multiple inverters, verify that the LGate is measuring the combined inverter output. Finally, if the LGate LCD screen is blank, ensure that the meter is firmly seated in the meter base and check the voltage on each line. We also recommend checking that there's no corrosion or sediment in the meter socket tabs, as this can prevent a secure connection. Now that we've gone over basic installation and best practices, we'll go over a few considerations for post-installation operations and maintenance. We'll go over the LGate 120 and 320 dataset and provide a troubleshooting case study to bring it all together. As I mentioned earlier, the LGate 120 and 320 will measure the following: power, interval energy, and lifetime energy. The LGate 120 will measure line-to-line voltage, and the LGate 320 will measure line-to-neutral voltage. The LGate 120 measures net amperage, while the 320 measures amperage by phase. Both meters will measure AC frequency. In addition to these variables, the LGate 120 and 320 will also measure apparent power, reactive power, power factor, and phase angle. These data points can help us evaluate system efficiency and often serve as the first clue in understanding why a system is underperforming. These data points are also available in the charting tool on Solar OS. To demonstrate how this expanded dataset can be useful, I'll go over a troubleshooting case for a recent LGate 120 installation. An LGate 120 was installed to monitor a 3 kW single-phase PV system. We noticed that the LGate was reporting high current draw at night. In this chart, you can see power graphed in orange and current graphed in purple. At first, we suspected an installation error or a site design flaw, which would probably require a site visit by the installer. Before sending someone on site, we took a look at the data in the charting tool and found that power factor, which is the ratio of real power to apparent power, hovered right around 1 for most of the solar day, so it was a pretty efficient system. At night, this dropped to 0, so nothing unusual there. In this chart, you can see power factor graphed in red. Next, we graphed reactive power against current and real power. In this chart, you can see reactive power in blue. We noticed that there was extremely high reactive power at nighttime, upwards of 100 volt amperes. When the inverter was running during the solar day, reactive power stayed within a fairly reasonable range. In the end, we were able to determine that the inverter was drawing significant amperage at night, but close to 0 kW. We learned that this is fairly common behavior for the inverter they had on site, which was an older model. Without the expanded dataset from the LGate 120, we might not have been able to figure this out without a site visit. This concludes the LGate 120 and 320 online training guide. For additional questions, please feel free to contact the Locus Energy support team or your account rep. Thank you.